Welcome to week 10. We're going to start on something completely new this week. As I told you, towards the end of the last lecture of week 9, we saw what we did till now. We mainly did coverage criteria and saw various kinds of testing using this model or that structure, graphs, logics, sets, and so on. This week, I'm going to take classes of applications. We are going to start with web applications, web software, move on to object-oriented applications. We learn a bit about those applications. We learn problems that are unique related to testing about each of these applications. We'll compare and see the coverage criteria that we have learned so far, whether they can be directly used to test these applications or not. And if not, I'll tell you new algorithms that can be specifically used to test applications. So we're going to begin this week by looking at testing of web applications. So this is an overview of what we're going to do over the next few lectures. Today, I'll introduce you to relevant aspects of web applications. We'll see what they are. And then we'll also discuss what are the specific issues that come with testing of web applications. And then when it comes to testing, it helps to have the following broad categorization. We'll test what are called static hypertext websites that remain the same, look the same to almost every user who accesses it all the time, basically have nothing more than HTML files. And then when it comes to testing, it's important to separately consider dynamic web applications. In dynamic web applications, the content of the web page is created dynamically by an underlying application or a program. Here, usually the kind of code that's written for the server side is very different from the kind of code that is done for the client side. Hence, the testing that we have to do for the client side and server side are also very different. So this is a structure of what we're going to see about testing of web applications put together. Today, I'll begin with introducing you to the relevant aspects of web applications. Please remember that this is not meant to be a comprehensive introduction to what a web application or a web software is. Feel free to look up other courses or online material for that. I'll just give you a bird's eye overview of what it is and consider it as understood from the point of view of testing. Our issue will be to focus on testing, not to thoroughly introduce you to web applications. So what is a web application for us? For us, a web application is a program written in some language, right? But the program difference is it's not deployed in the computer, it's deployed on the web. What do we mean by it's deployed on the web? It's basically deployed in a computer that's meant to act as a server for further deployment or availability on the web or the internet. What is the user interface that this kind of web application uses? It's basically HTML, stands for Hypertext Markup Language, standard language that people use to write web pages. Web deployment means what? It's available on the internet worldwide. As long as you have access to it, you have access to this website. And typically, a web application, how does it talk to a user, an end user? It talks to an end user through a server that accepts requests from an end user or a client through HTTP. HTTP stands for Hypertext Transfer Protocol. It's a standard protocol that's used in the internet, and it also returns responses, which are websites basically, or information provided by a web page through HTTP again. So this is a web application for us. So it is a lot like a classical client server application. The only difference is the server is a web server meant to host the application on the internet, and the client runs in a web browser. What are web browsers? Internet Explorer, Mozilla, Google Chrome, and so on, right? So here are examples of classical web applications. We all use webmail, some form of the other, Gmail, Microsoft Office Outlook, Yahoo Mail, Hotmail, and so on. We also use a lot of online retail sales, Amazon, Flipkart, and so on. And we use wikis. These are various categories of web applications, and lots more are also there. There are a slightly special class of web applications called web services. What is a web service? Web service, like a web application, is another program that's deployed on the web. It accepts XML messages that are wrapped in SOAP or RESTful services. Usually it has no interface with human. It directly talks to programs or clients, and the service must be published so that other services and applications can discover a web service. In our lectures, when we focus on testing, we won't really explicitly consider web services as a standalone, separate kind of web application. We look at generically testing web applications as we introduce them here. So, what are the general characteristics of such web applications or web software? I'll use the term web app, web application, web software, all these terms synonymously, they all mean the same for us. Web application is composed of several independent, loosely coupled program components. How do these loosely coupled program components talk to each other? How do they constitute one web application? They communicate with each other through message passing. The interface that they use is message passing interface, and these messages from the application always go through dedicated entities called clients, and sometimes they do shared memory, but it's very restricted. It is through what is called session objects. And the definition of a state of a program, we know what it is. It means the class of all, set of all variables of a program and a location counter. But here, the state of a program as a web application is usually quite different, doesn't correspond to the classical notion of a program state. As I told you, because it consists of independent, loosely coupled components, a web application is a distributed or a concurrent application, and it has several components, each of them very small. And not only that, each of these components could be developed or written, processed using a completely different technology. For example, somebody could do JSP, Java server pages, somebody could do ASP, somebody could just write Java, Java Beans, JavaScript, Ajax, PHP, HTML. If you go and search for web technologies and web applications, you'll find all these terms thrown across. My goal again, to reiterate, is to not to exhaustively introduce you to these terms, but to more bring it up as one of the characteristics of web applications. That when we put them all together to test, we have to handle in our tests several different technologies that come from completely different domains. That's important to remember. Typically, when I consider a software, any piece of software that you have, what are the various ways of deploying it? This is not specific to web applications or web software. Any generic software. You could bundle a software, in which case it's usually pre-installed on a computer. Like for example, if you buy a package, if you buy a computer, then the operating systems in the computer comes bundled along with it. It's pre-installed the way you want it. You could shrink wrap. A typical example for this is you buy the software and install it, like an antivirus software that you would buy and install. Or you could have a contract software where you have access to the software but for a specified period of time that you buy the contract for. And you could have embedded software, which is usually installed on a specific purpose, special purpose hardware device, like in a microwave oven, in a car, in an aeroplane, and so on. And it typically directly communicates only with sensors and actuators in the embedded device, doesn't communicate with the user. And then now the focus of this lecture is what is called web software. How is it deployed? It is executed across the internet through HTTP protocol, typically hosted by a dedicated server for this purpose called the web server. Now, let's look at web application. Consider the typical architecture of a web application. The architecture has several layers where separation of concerns happen. There is something called one of the higher layers of the architecture is a presentation layer where the HTML and UI output are visible. Then comes the layer that contains the data called the data content layer where the actual computation and access to data happens. Below the data content layer is a data representation layer where the data is stored and retrieved in memory. And finally, you have data storage layer, which represents permanent data storage that happens because of a web application. Testing each layer separately is important. And what is also important is to do system level testing where you test for integration across these layers that do separation of concerns in a web application. Here are some generic issues with web applications. They, as I told you, are heterogeneous, dynamic, distributed, and because they are available freely across the internet, typical expectation is that they must be of very high quality. They can't be slow, they can't have a bug, they have to be reliable, they need to respond very quickly, so their quality attributes and expectations from these software is very high. But you might know by experience that there are so many low-level software that actually hinder the use of these web applications. Now let's move on and discuss specific issues related to web applications. As I told you, all web applications and web software use Hypertext Transfer Protocol, HTTP. What do we know about HTTP? It's a stateless protocol. What do we mean by it's a stateless protocol? Suppose there is a new HTTP request, it's completely independent of the history. It's completely independent of the previous requests, the requests before that, and so on. So if it's a stateless protocol, how do people manage state when they deploy web application? You all might have heard of the term cookies, session objects, and so on, right? So those are basically entities that web programmers or web app developers use to manage state information whenever needed. The next is web server typically has very little information about where a request comes from. It could be from a malicious client, it could be from a genuine client. Typically, you do a lot of authentication and authorization, but still there is very little information about where exactly the request is coming from and what happens to the response in turn. Web software, as we discussed earlier, is extremely loosely coupled, right? Extremely loosely. There is importance to that word. Why? There is something called tightly coupled and loosely coupled. Here, I add one more qualifying adjective. I say it's extremely loosely coupled. Why is that so? Because it's coupled through the internet, which means what? The software is physically separated in space. It doesn't reside in one entity. It doesn't reside within one server. It's also coupled to diverse hardware devices. It could be anywhere, in any part of the world. And as I told you, it's written using diverse technologies and a diverse set of software languages. Let's look at all the techniques that we have learned so far and analyze one at a time about whether any of them will be useful for testing web software. What did we begin the course with? We taught graphs to start with. But what were the graph models of software artifacts that we considered? We considered control flow graph, we considered call graphs, and so on. If you see, none of these kind of models apply for system level testing of web application. Of course, you could consider one individual program that's written as a web application, and if you're doing unit testing for that program, then you could consider the control flow graph, do your coverage criteria. But that's not what we're talking about. We're talking about system level testing of a web app. In that case, working with control graph or call graph doesn't really apply because the program is distributed across the internet. The other thing is, we also learned about state machines, the specific graph models that model the state behavior of software. Here, state behavior of a web application, if you think about it, there is some part of the server state, there's some part of the client state. Different clients have different states. It's quite a hard task to model the state. Typically, all the next important issues are related to RIPR model or controllability and observability. Typically, both controllability and observability for web software is very low. Why is controllability low? Because all inputs, please remember, go through HTML files, right? So if I have to control an input, I'm talking about controlling the entire HTML file of an entire web page. It's going to be difficult to provide inputs that can be controlled within a user. And once you provide an input, let's say you manage to provide an input, you manage to get controllability, the next is to observe what happens in this for the state of a web program, which is hosted in a web server. It's very difficult to get access to server-side details. For good reasons, it's not secure enough and we typically don't want to. We don't know where the memories are, where the file is, where the database is. So from the point of view of testing, observability and controllability becomes very low. So testing becomes difficult. Now the other kind of software artifact that we learned were logic predicates, but it's not clear what kind of logic predicates can be effectively used to do system level testing. Again, the last one that we learned was related to mutation operators. To the extent that I am aware of, there are no known mutation operators specifically for web software. So it looks like most of the techniques that we learned cannot be directly put to use. We will use graph-based testing to some extent, but only for restricted websites that are static in nature. The rest of them, we really have to understand or develop pretty new techniques that could be based on the techniques that we've learned so far, but none of the ones that we've learned so far directly apply. So now we'll revisit the specific problems of web applications because it's useful to know when we are designing testing techniques. So as I told you, they are very extremely loosely coupled. Over the internet, there's diverse hardware and software. And I told you HTML forms are created dynamically by web applications. So there is very little controllability and observability on the input. The user interface that's provided through a HTML file can vary, and it's created on demand based on the credentials. And users can change the flow of control arbitrarily. In the middle of a transaction, as a page is loading, somebody could press a back button or a forward button, could press a refresh button, right? That's why when you handle secure transactions like bank and all that, you explicitly get messages saying do not press back button. But typically for a normal web application, there's no expectation that nobody will press the back buttons. So as you're testing, while your input is executing, while your program is running, if the control changes, then what you observe may not actually correspond to the actual web app or the web software behavior at all. So it's quite a dicey thing. And the other thing is that dynamically new software components can be added into a web application. So all these are issues. When it comes to testing, we prefer to bucket web applications into 3 different categories. We'll separately deal with what we call static hypertext websites, which are basically plain HTML files that are written once, put on the web server, deployed, and not touched. And then we'll separately deal with testing dynamic web applications. On that, we'll do separately client-side testing and separately server-side testing. As I told you, we really won't exclusively consider testing of web services. We'll generically deal with testing of web applications. The last topic here, we will not specifically consider it. So just to redefine a few terminologies that we will need for the rest of the few lectures. For us, a web page contains HTML content, and it is typically viewed in a browser, single browser window. It can be a static HTML file, or it could be dynamically generated by using JSP, ASP, or any other kind of web software. A website is a collection of web pages, static and or dynamic, and is associated software element that are related semantically in a meaningful way by their content. And how are they related syntactically? They are related syntactically by hyperlinks and other mechanisms for passing control from one web page to the other. Hyperlinks, forms, and so on. A static web page never changes. It's the same to all the users all the time as long as it's available, usually stored as a HTML file on a dedicated web server. In contrast, a dynamic web page is created by a program or a web program, web software on demand. Its contents and structure typically depend on previous inputs from the user, state of the web server, other inputs like where the user is from, what time of the day, what is the data provided by the user, and so on. For us, when we test web applications, it helps to first think back and understand what will a test case for a web application be. A test case for a graph will be a path. A test case for a logical predicate will be true, false values to the inputs. A test case for mutation-based testing would be any value that kills the mutant, and so on. Similarly, what is a test case for a web application? A test case for a web application is basically a sequence of interactions between components that reside on the clients and the components that reside on the server. How are they given? Test case is usually depicted by a path that contains states and transitions through the various web applications. These paths have to be generated for static and dynamic websites. For static web pages, it's easy to do. For dynamic websites, it can be challenging, mainly because, as I told you, you could have users changing the flow of control arbitrarily. So if you generate a particular dynamic web content, halfway through the content being fed into the software as an input, the nature of the software itself could be changed by the user. So just as a recap, what is a test case? A test case is basically a sequence of web pages which are given as a transitions through the web applications, easier to create for static websites, little more difficult to create for dynamic websites. So we'll begin by looking static websites in this lecture. Next lecture, I'll begin by doing dynamic websites. In static website, what does a web page look like? There is no program involved at all. Please remember that. Maybe there is some scripting involved. The ultimate content to test is a set of plain HTML files that never vary. This is not program testing because there is no program. But what does this testing do? It basically checks that all the HTML connections are valid. right? If one hyperlinks another one, that connection is valid and it goes to the intended page. Not only does it go to the intended page, you also check that a particular hyperlink or a connection that is there available from a website doesn't go to any URL that is dead or defunct or no longer valid. So such kind of testing should also include testing for what are called dead links. Dead links are those that are links, hyperlinks to URLs that are not valid anymore. Typically, when it comes to system level testing of web applications, people also evaluate several non-functional parameters. They test the load of a system. Classical example would be, let's say you use IRCTC web application. Load testing would be to let's exercise maximum number of users that the system can scale up to. Let everybody log in and see if the system is still able to smoothly let the person transact and book his or her ticket the way he or she wants. Another thing is performance evaluation, which basically talks about the efficiency of response to of a web application. The third is access control issues, in the sense that you need certain kind of accesses to be able to access certain kind of dynamic web page. Like for example, if you're accessing your bank web page, before you actually get down to the dynamically created content that gives you your user account details, your access as a user needs to be authenticated by means of a login and a password. So system level testing of web applications also include these non-functional parameters. Our focus in these lectures would be on functional testing of system level parameters. So we won't really look at load or performance testing in this course. So when it comes to static websites, what is the model of testing that we use? It's not too difficult to see that graph models, as we saw, will always work. Of course, this is not a call graph or a control flow graph. This is a different kind of graph. What will be the nodes or vertices of this graph? The nodes or vertices of these graphs are the various web pages, each individual page. What are the edges of these graphs? Let's say you are in one particular page, there is a hyperlink. You click on that hyperlink, you go to another page. Then you say that there is an edge from the node corresponding to the first web page to the node corresponding to the second web page. So edges are HTML links. And how do you build such a graph? You typically build the graph by starting from an introductory page. In static pages, there will usually be an index.html or a welcome.html, which is the beginning page of the static website. You start from there, do a breadth first search recursively by looking at each link from that page, and then go to the pages that it links to. Again, do a BFS to the links of that page, and so on till there are no further links to be explored. Once this graph is generated, what is the main aspect that is tested? The main aspect that is tested is classical edge coverage. What do edges of this graph represent? Is each link working fine? So edge coverage basically tests for traverse each hyperlink in the static website. So testing static websites, that's about it. There is nothing much. You generate a graph, vertices of the graph are web pages, edges of the graphs are hyperlinks, and then you do edge coverage of the graph. This basically tests for static website working correct, because there's nothing like performance load, there's no dynamic data. That's it. We are done with system level testing of static websites. Now, the next lecture, what I'll tell you is, let's move on and look at dynamic web applications. When it comes to dynamic web applications, as far as testing is concerned, as I told you, it helps to distinguish between the client-side testing and server-side testing. So we look at these two independently and see some new techniques or technologies or algorithms that have been developed for client-side testing and for server-side testing. And as I told you a couple of times before in this lecture, we will not look at testing web services exclusively. So I'll come back to you in the next lecture for testing dynamic websites. Thank you.